Well, welcome. In this video, we're going to be looking at lesson 3.6, and specifically, we're going to learn how we can use roots of a polynomial equation to find other roots. So let's start with the warm-up. So I want you to look at the polynomial functions that are shown, and we have Avery, who has a conjecture. Conjecture, remember, is just a possible rule. So she's trying to create this rule, and she has this conjecture that the zeros of a polynomial function have to be positive or negative factors of its constant term. So the constant term, remember, is the number without a variable. So in that function g of x, the constant would be 18, or negative 18. And so what I want you to do is I want you to factor down x squared minus 7x minus 18 to find the zeros of that polynomial. Remember, you set each factor then equal to 0 and solve it. And I want you to see, is your conjecture true based on what you just found? Are those zeros, in fact, factors of the constant, negative 18. And then we're going to test that conjecture on letter B. So letter B, it says, now test Avery's conjecture by factoring h of x. Does Avery's conjecture hold? If so, explain why, and if not, make a new conjecture. So make a new rule. So I want you to see if her conjecture actually works with function h, and if it doesn't work, see if you can manipulate it to change the conjecture so it would be a true statement. So go ahead and pause this video and hit play when you're ready to check to see if you've factored those and found the zeros correctly. All right, let's see how you did. So in that first one, when we solve or factor x squared minus 7x minus 18, it factors down to be x minus 9 times x plus 2. Remember, when that a value, when that leading coefficient is 1, when we're dealing with the quadratic, you can skip that whole box method by just looking to find two numbers that multiply together to be negative 18, that add together to be the middle term, negative 7. And that would be negative 2, or negative 9 and 2. Because negative 9 times 2 is negative 18, and negative 9 plus 2 is negative 7. All right, so then you find your zeros. We set each of those factors equal to 0 and solve, and we would get a positive 9 and a negative 2, which those are factors of negative 18. So maybe Avery's conjecture is true. Let's look at the letter B. So letter B, if you factor that down, now that does not have an a value, it does not have a leading term of 1. So we can't use the shortcut that we just did in the previous one. So we have to use that box method. So remember, we start by putting the 5x squared in the top left corner and the 16 in the bottom right corner. And our goal is to try to figure out how do we break apart that 24x in those other two boxes. And so you do that by finding two numbers that multiply together to be 80x squared, or just 80, that add together to be 24. And that would be 4 and 20. So 4x and 20x multiply together to be 80x squared, and they add together to be 24x. So then when you break this apart, when you factor it down, you get x plus 4 times 5x minus 4. So our zeros are negative 4/5 and negative 4. So are those two actually factors of 16? Well, negative 4 is a factor of 16, because negative 4 times negative 4 would be positive 16. Negative 4/5, though, is not a factor of 16. So maybe you changed the conjecture, maybe you didn't. Maybe you changed the conjecture to say, well, that rule, her conjecture, her rule only works when the leading coefficient is 1. That would be fine. But on the next screen, we're going to learn about something that's actually going to create this conjecture for us, or create this rule for us. And that's this. This is what we call the Rational Root Theorem. Now, I don't want you to freak out when you see that let p of x equals that string of just foreign language there. Let me help you break that down so you can understand what that means. That is, in general terms, that is how we describe a polynomial, where if you look at the very beginning, a sub n refers to the leading coefficient. And then you would have x to the nth power, so n would refer to the degree of the polynomial, because if you have it in standard form, you should be starting with the term with the largest exponent, so n would be the degree of the polynomial. And then from there, it's only going to get smaller as you go down. So we would have, and actually the book has a typo here, this should be n minus 1, because the exponent should go in descending order as we get smaller. So the next term, we would have the coefficient, whatever that would be, times x to the n minus 1 power. And then as we go down, we'd end up with x, or this should just be the first power, so that's right. So we would have the last term, we have x to the first power down to our constant. Our constant is a sub 0. So out of all that, don't worry so much about that whole string and trying to make sense of it all. the two things that you need, actually technically three things, but the two things that they emphasize here are that a sub n is your leading coefficient, and a sub 0 is what we call our constant term. So that's going to not have a variable attached to it. The other thing to take away from that gibberish is that n would be the degree of the polynomial. All right, so what are we going to do with that a sub 0 and the a sub n? Here's what the rational root theorem tells us. So you want to make sure that you write that phrase, rational root theorem, down in your notes and what it means. And so that's what I have highlighted here. Now, I try to use some color coding with my highlighting. So first off, the main idea is that each rational root, any rational root from that polynomial, so any root, any x-intercept, any solution to that equation when it's equal to 0 is going to be in the form p over q, where p is a factor of the constant term, whatever that is, and q is a factor of the leading coefficient, a sub n. So right now that doesn't make a whole lot of sense. Let's look at an example to make more sense of this. So let's look at this scenario. So here we have 8x to the fifth minus 32x to the fourth plus x squared minus 4. Without substituting, how can you determine if 4 is a possible solution to that function? Where if you put 4 in there, you'd get 0 as your answer. So we don't actually want to substitute it in. Now, we could look at the graph and we could see from the graph that it looks like it might be 4. But we can use a rational root theorem to actually determine if 4 is a root. Because remember, from that rational root theorem, any root is going to be in the form of p over q. So so we're going to list all the factors of the leading coefficient and the constant. Okay, so if let's start with the constant, because the constant is going to be put in the numerator. So the constant term is 4. Don't worry about the negative, it doesn't matter. The constant value would just be 4. And the factors of 4 would be 1 and 4 and 2 and 2. So the way we'll write that is in order. And we would say plus or minus 1, positive or negative 2, or positive or negative 4. So those would be the factors of 4. Now the leading coefficient is 8. So let's list the factors of 8. So the factors of 8 would be 1 times 8 and 2 times 4. Again, we're going to use plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. It's just easiest if you just put them in order from smallest to largest. If you're wondering why we have to have plus or minus, it's just so that we have all of our bases covered, so we can come up with any positive or negative solution. Okay, so just know that it'll always be positive or negative. Now remember, the actual root, or actual roots I should say, are going to be we're going to set all these up as fractions. So we're going to take, it's going to be p over q, all the possible factors of our constant over all of our all of our factors of our leading coefficient. So I'm going to kind of phase myself out here so we could see all of the possibilities. Now it might look like there's a lot there. And yeah, there is a lot when we look at it the way that the book did there, because they want to include every single one. So one way that you could do that is you could start with the factors of 4. So the factors of 4, we have 1. Let's start with the 1. So we could have 1 over 1 from the leading coefficient of 8. So we're comparing the two, we're setting up the two, the sets of factors there as fractions. So we'd have 1 over 1, which would just be 1. We could have 1 over 2, plus or minus 1 over 2. We get a plus or minus 1 over 4 and plus or minus 1 over 8. So those are all possible roots of the polynomial. Okay, now 1 over 1, just if I were writing that down, I would just write it down as 1. Now 2 over 1 is the same as 2, so that would be another possible solution. Now 2 divided by 2 is the same as 1. So if you're writing this down, you do not need to include 2 over 2. They're just showing you, as far as all the possibilities, we would only write down the ones that would actually be unique. And so 2 over 2 is not unique, so we already have it as 1. 2 fourths. Yeah, we'd get 2 fourths, but 2 fourths is the same as 1/2, so no need to write that down again. 2 eighths. 2 eighths reduces to 1/4. We already have that written down, so we don't have to deal with that one. 4 over 1 is the same as 4, so that's a unique one. We haven't seen that one yet. And then we have 4 over 2. 4 over 2 is the same as 2. And 4 over 4 is the same as 1. And then 4 over 8 would be the same as 1/2. So the only unique possible solutions would be plus or minus 1, plus or minus 1/2, plus or minus 1/4, 1/8, 2, and 4. Okay, so those are all the possibilities. Now, and if you notice, 4 is one of them that's in the list. So this question, the only thing that this question was asking was, is 4, without substituting, is 4 a possible solution to that equation when it's equal to 0? And yes, it would be, based on the rational root theorem. So that's what we're trying to figure out. So here's what I want you to do. I want you to try the same thing for this problem. Okay, so I want you to list the factors of our constant. Our constant is 8 this time. And I want you to list the factors of the coefficient, which is 4. Make sure you do them in that order. The constant first, the coefficient second. So then that way you have them basically set up as fractions. And then list out all the unique possible outcomes that you could have for your solution. So I want you to do that for both A and B here. So when you get to B, our constant in that situation is 45, and our leading coefficient for that one is 7. So that one looks like it might be a little easier, but you'll see. So go ahead and pause the video and hit play when you're ready to check to see if you found all the possible solutions correctly. All right, so let's see how you did here. So for that first one, the factors of 8, we just did on the previous screen, but the factors of 8 would be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Factors of 4 would be plus or minus 1, plus or minus 2, plus or minus 4. So all the possible fractions we could get out of this, again, you don't have to, if it can be simplified, you can simplify it. You don't have to leave it as a fraction. So instead of writing it as 1 over 1, we'll just say 1. So it'll be plus or minus 1, 1/2, 1/4, 2, 4, and 8. Now I just want to emphasize that what we found in green does not mean that it has that many solutions. That's what we're going to be doing next, is discovering, well, which one or which ones of those are actual solutions, if any of them. Those are just the possibilities. All right, so what did you do for the next one? Hopefully you got as your factors of 45. Now there's a lot of factors of 45 because you would have 1 and 45, 3 and 15, 5 and 9. So a total of 6 factors, and then we got to include the plus or minuses for each of them. And then the factors of 7 are just 1 and 7. And so, but this one, when you go to list out the fractions, there's none that are reduced to be any repeats. And so you end up getting unique ones for every single possible solution. So make sure that you have all of those. How'd you do? Hopefully you got those all right. All right, let's look at this next slide here. So now we're going to use that to answer some story problems here. You're going to use this concept. So here it says, the storage company is designing a new storage unit. Based on the dimensions shown, the volume of a container is modeled by that polynomial 2x cubed minus 7x squared plus 6x, where x is the width in feet. What are the dimensions of the container in feet if the volume of the unit is 154 cubic feet? Okay, so we can see from the diagram the individual dimensions. So we can see the width is x, the length is x minus 2, and the height is 2x minus 3. And if you multiply those together, that would give you the volume. And so they've already done that dirty work for us. And they came up with 2x cubed minus 7x squared plus 6x. And so we know the volume of that container is 154 cubic feet. So we're going to use that information to figure out what the dimensions are. So if the volume is 154, we could, basically what that paragraph is saying is we can set that equation equal to 154. So we'd have 2x cubed minus 7x squared plus 6x equals 154. But before we find the zeros, we want to get this equal to 0. So we want to subtract 154 from both sides. So we're going to be working with the equation 2x cubed minus 7x squared plus 6x minus 154 equals 0. So now we're going to find all the possible factors of the constant term, which is 154, and the leading coefficient, which is 2. So they've done that for us. Now 154, there's a good handful of them there. That looks like there's 8 different factors. And then you include the plus or minuses for each of them. And the factors of 2 would just be 1 and 2. So we have plus or minus 1, plus or minus 2. So what we could do is we could list out all those possibilities. Okay? And so that's what I've done here. So if we list out all the possible solutions, that's what we would get. Now our goal, though, is to figure out what is, out of all of those, what is the actual solution? What is the one piece, what is the one number from that huge list where if you put it in that equation, you get 0 as your answer? So to help us out, what we're going to do is we're going to graph it. Now the x-axis, I counted by 1s here. Okay, so this is from, I graphed this on my TI-84, and the y-axis, that is not counting by 1s, but that doesn't matter. Okay, so all that matters is that the x-axis we're counting by 1s. So when I look at where that x-intercept is, if you count by 1s, it looks like it's somewhere between 5 and 6. So we want to go through that list and see if any of those numbers in the list would give us a value that's between 5 and 6. So obviously it's not 1 or 1/2 or 2 or 7. 7/2, what would that be as a decimal? That'd be 3.5. So no, that's not going to be it. It's not going to be 11 What would be 11 halves? Ooh, 11 halves, that would be 5.5. So let's see if there's any other ones. 14, nope, that's not going to be at 22. No, 77, no. 77 divided by 2, that's going to be way too big. 154, that's way too big. So the only one that we should try here is 11 halves. None of the other ones made sense. Okay, because again, we're trying to find out which one would be closest to that point between 5 and 6. And we have exactly 5.5 here, so let's try it out. So we're going to put 5.5 or 11 halves, doesn't matter which, into your original equation, the one that was equal to 0. And when we solve that, sure enough, you do get 0 as your answer. So that tells us that 11 halves is the solution. So now we're going to go back to what we were talking about originally, because our goal is to figure out what are the dimensions. So we just found what x is. We just found that x is 11, because that's the width of the container, is 11 halves, or we'll just say 5.5 feet. So the length is x minus 2, or 5.5 minus 2. So the length would be 3.5 feet. And the height is 2 times whatever x is minus 3. So 2 times 5.5 minus would be 11, and 11 minus 3 would be 8. So our dimensions would be 5.5 feet by 3.5 feet by 8 feet. So that's how you would do that. So again, the way that so just to kind of put it all in a nutshell here, we use the factors of the constant divided by the factors of the leading coefficient, so P over Q, to get all the possible solutions. And then what we're going to do is we're going to look at a graph, and from the graph, we're going to try to figure out, well, which one or which ones of those are our possible solutions. Okay? So you don't want to cheat on this and just go by on your graphing calculator and try to figure out the x-intercepts. I know that would be easier, but there's going to be times where we're going to provide for you a graph, and we're not going to tell you what the equation is, and you're going to have to figure out from a list of numbers which one would be the best solution to go with. Okay, so that's the way we might assess you on this on a quiz or on a test, because we want to make sure that you know how to list out the possible solutions. So we would have questions like that, and then we'd have another question where if you have all the possible solutions, how to figure out which one you would test to be the actual solution that would give you 0. All right, so I want you guys to try this one on your own. So this one, it says a jewelry box measures 2x plus 1 inches long, 2x by 6 inches wide, and x inches tall. The volume of the box is given by the equation 4x cubed minus 10x squared minus 6x. So it says, what is the height of the box in inches if the volume is 28 cubic inches? So remember, that formula, the 4x cubed minus 10x squared minus 6x, is our formula for the volume. So if we know the volume is 28 cubic inches, we could put 28 in there for the volume. Well, remember, we want to get it equal to 0, so we would subtract 28 from both sides. So now we'd have 4x cubed minus 10x squared minus 6x minus 28 equals 0. So I want you to go through the same process. I want you to start by finding out what are all the possible solutions that would work, that would give us x, that we could put in for x to get 0 as our answer. So I want to find all the possible solutions. Then I want you to look at the graph. I want you to estimate which one of those solutions you would try, or which ones of those solutions would work. And then I want you to actually figure out what the dimensions of the box would be based on your answer for x. So why don't you pause the video and go through that process and see if you can't figure out the dimensions of the jewelry box. All right, let's see how you did. So again, we're working with the 4x cubed minus 10x squared minus 6x minus 28. So we'd start with the factors of 28, which are 1 and 28, 2 and 14, 4 and 7. Again, plus or minus for each of those. And then the leading coefficient is 4. So we'd have plus or minus 1, plus or minus 2, plus or minus 4. And then when you look at all those possible fractions, well, personally, what I would do is I would look at the graph. We'd want to figure out, well, which one of those would be the best one to try. And so it looks like our graph is going somewhere between 3 and 4, where it hits the x-axis. So the only one that I could really try would be the 7 halves. Okay, because we would have 1 over 1, 2 over 1. We would have a whole list. I'm not going to go through them all. But the one that we would only make sense to try would be a positive 7 halves. And sure enough, if you put 7 halves into that function, you get 0 as your answer. So we know that 7 halves would be our solution. That's our value for x. And that's all they're asking for. They're asking for what is the height of the box. And the height of the box is x. And so it'd just be 3.5 inches, or you could say 7 halves inches. 3.5 inches would be better. All right, so that is the end of this first part of the video. So in the next part of the video, we're going to be taking this a little bit further. So hopefully you understand how to do these problems with how to find all the possible rational roots and how to use a graph to figure out which one would be the actual rational root. So good luck as you will be working on your assignment soon.